Hi, I'm from the Customer Success Engineering team. In this series of short videos, we'll be taking a look at recommendations for forwarding your traffic to the Zero Trust Exchange. This is part 2, the Zscaler Client Connector. As mentioned in the previous video, the Zscaler Client Connector is a lightweight endpoint agent that is installed on user devices and will encapsulate user traffic from all ports and protocols, providing a seamless, always-on forwarding experience. ZCC can detect if a user is on a trusted network, as defined by an administrator, and make routing decisions accordingly. ZCC is also the agent required for the ZPA and ZDX services. It supports the most common operating systems: Windows, macOS, Linux, Android, and iOS. It can be easily distributed through modern MDM or EMM solutions, and integrates with select XDR and EDR services for posture checking. It supports bypassing select destinations or services from being forwarded to ZIA. Here are some of the many benefits of ZCC. ZCC is a single client for the ZA, ZPA, and ZDX services. It encapsulates all user traffic on all ports and protocols, whether this traffic comes from a browser, an app, or something else. It is tamper-resistant. It authenticates user traffic with Zscaler services and provides user attribution and asset identification. It can optionally be configured for strict enforcement, where internet access is not possible for users not signed in. It has trusted network detection with the ability to configure different forwarding rules based on what network the user is on. It has the ability to detect captive portals and fail open to allow users to authenticate with them. It includes native packet capture and in-app access to Zscaler support. It is used to distribute the certificate required to inspect encrypted traffic. For these many reasons, it is strongly recommended that you install ZCC on all corporate user devices, especially all corporate laptops and desktops, virtual or physical. This is regardless of whether or not these users will be working from locations with GRE or IPsec tunnels set up. Next, let's briefly talk about the two different tunneling modes ZCC can use. When a user connects to the internet, ZCC will establish a tunnel to the closest service edge, which will apply policies to user traffic. This Z-tunnel can be established either as Z-tunnel 1 or Z-tunnel 2. Z-tunnel 1 uses HTTP connect for proxy-aware traffic on ports 80 and 443. Z-tunnel 2 is a persistent TLS or DTLS tunnel that encapsulates all unicast ports and protocols. With Z-tunnel 1, when a user connects to the web, ZCC adds authentication headers and forwards the traffic as a HTTP connect request. The service edge chosen for this will be based on the app profile logic configured, generally the closest in-country service edge, but this can also be configured to route traffic to a specific service edge if needed. The service edge will then authenticate the user based on information provided by ZCC, handle the connection request, and apply policies configured for that user. With Z-tunnel 2, ZCC will establish a persistent TLS or DTLS tunnel with the selected service edge, then forward traffic for all ports and protocols through this tunnel. This means Z-tunnel 2 is not limited to web requests only. The tunnel itself is authenticated and encrypted to ensure its integrity. Notably, forwarding all ports and protocols like this allows you to apply full cloud firewall controls and policies to non-web traffic for your users. In addition to this, Z-tunnel 2 also makes configuring bypasses for certain applications or to certain destinations much easier. For these reasons, it's recommended that you leverage Z-tunnel 2 as your primary method of forwarding user traffic to the Zero Trust Exchange. Zscaler recommends that you do this even when users are on-premise and behind GRE or IPsec tunnels. Doing this means ZCC will continue to provide authentication for your users' traffic, as well as attribution and asset identification, which can be used to build policy, and that it can be used to determine device posture. GRE and IPsec tunnels do not themselves provide these functions. Note that using Z-tunnel 2 on trusted network when traffic is also routed through a GRE or IPsec tunnel is not recommended, as this would double encapsulate non-web traffic and slow down the processing of your user traffic. Instead, you should route Z-tunnel 2 traffic directly to the internet. This will be discussed in more detail in Part 5 of this video series, which covers location traffic. Note that when configuring the ZCC forwarding mode, there are 3 additional options. For the sake of completeness, we'll briefly discuss these here, but it is generally recommended that you stick to zTunnel 2 as the forwarding method for all the reasons established earlier in this video. Tunnel with local proxy is a legacy forwarding method that uses the user's browser to explicitly proxy all requests to localhost on port 9000. This traffic is then routed through ZCC, which adds an authentication header and forwards it to the service edge inside an HTTP tunnel. As with zTunnel 1, this will only secure web traffic. Finally, in enforced proxy and none modes, ZCC does not tunnel any traffic. Instead, you rely on the configured system proxy for your user's device to forward traffic onto the Zero Trust Exchange. The difference between the two is that in enforced proxy mode, ZCC will reapply proxy settings at regular interval to ensure they are enforced, which is not the case in none mode. Like TWLP, this can only secure web traffic and is not recommended. Zscaler recommends using zTunnel 2 wherever possible. That's it for this video. Thank you for watching.